Hello everyone. Welcome to channel by Ms. Nidhi Banga. Today we will talk about a part of grade 10, a portion of grade 10 chemistry, which in my experience, students find a little confusing. We will be doing 3 sets of reactions, which since they are spread along the 4 chapters, students often fail to compare and contrast them, and therefore they struggle with remembering the products. So my intention today here is to help you with that. This is the first equation, reaction of zinc with acids and bases. Now see, we know that metals react with acids, dilute acids, to give salt and liberate hydrogen gas. This we know, this is a very general reaction. Now, zinc is the only metal in your syllabus which would react with acids to liberate hydrogen gas. It would also react with base to liberate the same thing, hydrogen gas. But obviously the salt that would be formed is going to be different in both cases. Now, my intention here today is to tell you how to derive the formula of the salt, especially the salt that is formed between zinc and sodium hydroxide. Okay, so the first one, there's a very simple process. Some of you know that zinc has +2 valency. So it would need 2 chlorides to satisfy its valency, therefore it would form ZnCl2. But if you are ever confused in that, there's another method. See, this much you know, this much is easy. Now you can see that there are 2 hydrogens here. If there are 2 hydrogens here, we need to put a 2 here to balance the number of hydrogens. Now, what are we left with? We are left with 1 zinc and 2 chlorine atoms. So let's write the formula in this way, 1 zinc and 2 chlorine atoms. This is the logic behind writing the formula of any compound. That if you have 2-3 elements, let's say easiest 2 elements, one is going to be more metallic than the other. The one that is more metallic would be written first, followed by the less metallic. So here we have zinc and chlorine. Zinc is the metal, chlorine is the non-metal. So zinc would be written first, chlorine would be written next. Now, coming on to the second reaction, same logic we will follow. Write the reactants, write what is obviously liberated, that is hydrogen gas. Since 2 hydrogen atoms are here, we would put a 2 here. Now, what are we left with? We are left with 1 zinc. How many sodiums? 2 sodiums. How many oxygens? 2 oxygens. We would write the formula using these elements going from most metallic to least metallic or metallic to non-metallic. Now, oxygen obviously is the non-metal. Out of zinc and sodium, which one is more metallic? Sodium, of course. We know that sodium is a metal which is very aggressive. It reacts very quickly with water and air, and with water it also it also catches fire. So obviously it's very reactive. That means it's more metallic. Okay, so sodium would go first. There are 2 of them, so we would put a 2 here. Zinc would go next because it's more metallic than the oxygen, which would come next. Okay, 2 oxygens, so 2 oxygens here. This now is your, sodium zincate. Okay, this is the formula for sodium zincate. I hope this method would help you to find out the formula and never be confused about it. Our next topic is, not next topic, the topic that is related to this, close related to this, is amphoteric oxides. Now, oxides we know are of 2 kinds, metal oxides and non-metal oxides. Metal oxides are the ones which are basic. Non-metallic oxides are the ones which are acidic, right? These are the generalizations. So that means if metal oxides were to react with acids, since metal oxides are base, if they were to react with acids, they would give you salt and water. Common neutralization reaction. When base reacts with acid, it gives salt and water. Similarly, if a non-metal oxide would react with a base, it would again give you salt and water, right? since non-metal oxide is acidic, it would react with base to give salt and water. Now, there are numerous examples of this given in your book. That is not my point of focus today. My point of focus is amphoteric oxides. Ampho means both. Okay, for example, amphibians are the animals which can live on land and water both. Ambidextrous are the ones which can write with both hands. Okay, so it means both. Amphoteric oxides, therefore, are the oxides which can react with acids and bases, both. Not either one of them, both, always. Okay, and there are two of them in your syllabus. Amphoteric oxides, there are two of them in your syllabus. One is zinc oxide and the other one is aluminium oxide. These two are the amphoteric oxides in your syllabus. We will now study the reactions of these oxides with acids and bases. Since they're amphoteric, they are going to react with both acids and bases. So let's see. All right. The first reaction is between zinc oxide and HCl. Okay. Now, since it's acid, this is going to be base. Acid plus base gives you salt and water. Write water first. 2 hydrogens are needed. Put a 2 here. What are you left with? You're left with 2 chlorides and 1 zinc because oxygen is already taken care of, right? So just write zinc because it's more metallic than chloride. This is your zinc chloride. Okay. Similarly, since this is base, zinc oxide here is going to act as an acid. Okay. If it's an acid reacting with base, it's going to give water as a product. Now, since that's water, 2 hydrogens, put a 2 here. If you put a 2 here, then see what are you left with. See, 1 oxygen, 2 more oxygen, 3 oxygens. But out of 3 oxygens, 1 oxygen is taken care of. That means we are left with 2 oxygen, 2 sodium, and 1 zinc. Okay, just write them in the order of most metallic to least metallic. Sodium would come first, then zinc, and then oxygen. Okay. Again, this is your sodium zincate. Now, let us compare this with what we have done already. Okay, now let us compare the reactions of zinc with acid compared to zinc oxide with acid. The thing is, they are very, very similar. You see, this was the reaction of zinc with acid. Zinc plus 2HCl give you ZnCl2 plus hydrogen gas. Now compare it with the reaction of zinc oxide with HCl. You would see that the products are same. The only difference is you add an oxygen here. So in the product, oxygen gets added to the hydrogen. So basically, if you remove these 2 oxygens, this reaction is very much the same as this reaction. Okay, the only difference is oxygen here and here. Rest everything is same. Similarly, if we compare the second reaction of zinc oxide with sodium hydroxide, here zinc with sodium hydroxide. Again, the same comparison you would see that the only difference is oxygen here and here. If you remove these 2 oxygens, the reaction is the same as this reaction. Okay, so I hope this comparison helps. Now, it's time to talk about our next oxide, aluminium oxide. Aluminium oxide is also an amphoteric oxide, but the main thing about this is, please remember that this is the amphoteric oxide used in thermite process. It's a question that's very commonly asked. It's been questions in board exams as well. That name the amphoteric oxide used in thermite process and write its reaction with acids and bases. Okay, so since we have 2 amphoteric oxides, this clue helps us to know which oxide is being talked about. So it's the aluminium oxide. When it reacts with acid, here also you would get a salt and water. Here also you would get a salt and water. Now, here we would go the old school way because that is more easy. You know that aluminium has valency of +3. So that means 3 chloride would be required to balance its valency, right? Since chloride has -1, aluminium has +3, chloride has -1, crisscross, it will give you AlCl3, right? Now, let's talk about balancing. 2 aluminium here, 2 aluminium here. Now, it gives us 6 chlorine atoms, put a 6 here. This gives us 6 hydrogens, put a 3 here. Okay, so this is your first reaction. Very straightforward, no confusions here. Now, the next reaction is a little bit trickier than this one, but otherwise not much. Okay, so again, here you have a base reacting with amphoteric oxide. So this oxide would act as an acid. Acid plus base gives you salt and water. Now, water is removed. That means 2 hydrogens are in the product. So you have to put a 2 here to balance the number of hydrogens. Now, again, the same method. What is left? You have 2 sodiums that are left. You have 2 aluminiums that are left. Coming on to oxygen. There are a total of 5 oxygen in the reactant side. 3 here and 2 here. Out of the 5, 1 is taken care of. You are left with 4 oxygens. Now, if you look at the number 2, 2, 4, we can easily take 2 common. If we take 2 common, what are we left with? 1, 1, 2. That means 1 sodium, 1 aluminium and 2 oxygens. Write these elements going from most metallic to least metallic. Again, we know sodium is the most metallic. Next is your aluminium and then next is your oxygen, which is basically a non-metal. So here is the formula for sodium aluminate. I hope this method of writing the formula of compounds has helped. If you like the video, please subscribe, share and like, and I'll see you more. If you need any help with any other topic, please let me know in comments. And until next time, bye.